Poisson process is defined by the following properties. 1. The number n of T1, T2 of the points Ti in the interval T1, T2 of length T equals to T2 minus T1 is a Poisson random variable with parameter lambda T. Probability of n of T1, T2 equals K equals E of negative lambda T times lambda T to K over K factorial. 2. If the intervals T1, T2 and T2, T3 are non-overlapping, then the random variables n of T1, T2 and n of T3, T4 are independent. 3. At a time moment t, there is no more one Poisson point. Using the point T1, Ti, we form the stochastic process x of t equals n of 0t. Find the question A, E of x of t, and B, R of T1, T2. Probability of x equals k equals e to the negative lambda, lambda to k over k factorial. Sum k to. So we have sum k equals to 0 to infinite, e to the negative lambda, lambda to k over k factorial equals 1. Sum k equals 0 to the infinite, lambda to k over k factorial equals e to the lambda. And d over d lambda, sum k equals 0 to infinite, lambda to k over k factorial equals d over d lambda, e to lambda. So sum k equals 0 to infinite, k times lambda to k minus 1 over k factorial equals e to lambda. Sum k equals 0 to infinite, k times lambda to k over k factorial equals lambda times e to lambda. Sum k equals 0 to infinite, k times e to the negative lambda times lambda to k over k factorial equals lambda. So e of x equals sum k equals 0 to infinite, k e to negative lambda times lambda to k over k factorial equals lambda. Sigma square equals e of x minus eta square equals e of x square minus eta square equals e of x square minus lambda square. Sum k equals 0 to infinite, k times lambda to k over k factorial equals lambda times e to lambda. D over d lambda times sum k equals 0 to infinite, k times lambda to k over k factorial equals d over d lambda. Lambda e to lambda equals e to lambda plus lambda times e to lambda. So sum k equals 0 to infinite, k square times lambda to k minus 1 over k factorial equals 1 plus lambda times e to lambda. So sum k equals 0 to infinite, k square times e to negative lambda times lambda to k over k factorial equals 1 plus lambda times lambda. And the sigma square equals e of x square minus lambda square equals 1 plus lambda times lambda minus lambda square equals lambda. So we have e of x of t equals lambda t, and e of x square of t equals 1 plus lambda t times lambda t. Sigma x square of t equals lambda t. Question B. Question B. For T2 greater than or equal to T1 and x of T1 equals x of T1 minus x of 0, and x T2 minus x T1 are independent. So R of T1, T2 equals E of x T1, x T2 equals E of x T1 times x T2 minus x T1 plus x T1 equals E of x T1 times E of x T2 minus x T1 plus E of x square T1 equals lambda T1 times lambda T2 minus lambda T1 plus 1 plus lambda T1 times lambda T1 equals lambda times T1 plus lambda T1 T2. For T1 greater than or equal to T2, we can have R of 1. We have R of T1 T2 equals lambda of T2 plus lambda T1 T2. So R of T1 T2 equals lambda minimum of T1 T2 plus lambda T1 T2.